yeah, I just want to make sure that we have a context that we're talking about. So Sarah's question is about, well, if I have even though I only have one univariate variable that I want to protect.
Maybe drawing.
Sorry?
Are you drawing on that?
No,
okay.
no, sorry, yeah. I'm not drawing, actually. I'm just trying to get the new set of slides. It usually takes time, but thank you. Okay, so let me get that here. And it's also on our GitHub page, so if you want to take a look, it's there. So Sarah's question is, well, say, okay, so Sarah's question, let me just phrase it in what I prepared here. We're talking about, well, you can add random noise to a univariate variable that I want to protect for, okay? And you can add random noise through this Bayesian data synthesis process that you model it and then you generate new ones out of it. And I mean, an even more fundamental way that you can do it is, well, I don't care about like the distribution of this particular variable at the moment. I can just add a random noise from a normal distribution to do that, okay? And you can do it center at 0 for this because when you center at 0, the mean of the distribution wouldn't change, right? But the variance, because of, well, if I'm just having this family income here that I want to protect, I add a random noise from a normal 0 sigma. And if sigma is large, you're adding too much noise, maybe. If sigma is small, you're maybe not adding enough noise. And that again goes back to the trade-off between utility and risks. Okay, so that's whatever that I prepare over here. And I should mention this approach will preserve distributional characteristics of family income itself. Okay, to some degree, depends on how big your sigma is. Or if you don't use this, but use the Bayesian model that we talked about, the toy example, that you estimate, you model it, and you get a good sense about its mean and variance, and then you can generate synthetic data out of it. But like what Sarah is saying, how can you keep the relationship of this variable, which is the family income, with the other ones in your synthetic data? Okay, so if you imagine, well, I know my family income is sensitive. If when I'm doing my Bayesian modeling, if I only model this variable alone, in this case, we can just use the toy example where we had the Bayesian synthesizer as the normal model, right, just for this variable. I mean, unless you're super lucky, otherwise you would never capture any relationships, right? So, so what I want to say is, it's really important to think about what kind of relationships you want to preserve in the first place, because, well, that will have to go into the modeling process, okay? The flip side of that is, well, how would you know the users at the end of the day going to do what kind of analysis, right? So it's sort of like at this stage, I think we're just trying our best in a sense that, well, let's maybe guess what the users or data analysts in the end will want to do and factor those into our model as much as we can, and then see how things turn out to be. Okay. So short answer here, I guess, is if you have relationships in mind that you want to preserve, then you better factor that into your model. Okay. And in the particular example that we're working today is the C sample. Well, I won't bother you again of all of the detail. You know this, I think, by heart now because of all of the examples that we did in the past. But this one, again, just so you know, we are just limited for 4 variables for now, limited with 4 variables. Urban, rural, which is a binary, okay? Income is a continuous univariate. Race is a categorical, I think has 6 levels. And expenditure has, I mean, it's a continuous as well, okay? So on the next slide, we have this table, again, data dictionary for the 4 variables. Okay? So urban, rural, if it's 1, it's urban, where the consumer unit is at, and 2 is rural. Income is the amount of CU income before taxes in the past 12 months. Race is the race category of the reference person, okay, has 6 categories. And expenditure is continuous, it's the total expenditures in last quarter, okay. Yeah, because the reason I think why the expenditure is last quarter but the income is just how the survey was conducted, Okay, they do this interview every quarter, and then they collect. If you are selected, like in the sample, that consumer unit, you have to report your amount of income, the entire consumer unit before taxes for the last year. And then for the expenditure, it's only about last quarter. Okay, so that's what we have. So let me see. So before I go on, maybe it's a good time to have you like exchange. Well, so first of all, which are the variables you think are the sensitive? If you have to pick one, which one? If you think more than one are sensitive, why? Give some reasons. And second, I guess once you make that decision, like say if I know I want to protect a particular variable, then in my synthetic data or in my synthesis model, what kind of relationships I want to preserve? Because like we said earlier, that the relationships to preserve actually will go into the modeling process. Okay, you want to keep that information into the model, design your model around that idea. So the synthetic data that you generate in the end will be able to capture that. Okay, so I think this is part of the to-do list that I asked you to do before today. So maybe it's a good time to, if you have some results on your laptop, feel free to share that with your neighbor. We can also have you join the meeting, so we can have you share your screen if you want to talk about it to the class. Okay, so let's take some like a short discussion break here. And maybe, well, I hear some other concerns, which is good to raise if you feel like it, like when we get this going. So maybe we start with the question I had first, like say, among the four, if you have to pick one to be synthesized because you think that's the most sensitive, which one you would choose? And if you have more than one, feel free to share them as well. And then the second follow-up question from that is, well, if I determine, say, race is the most sensitive, I want to synthesize it, then what kind of relationships that I want to preserve? When we say relationships, it's about, like, say, relationship between this variable and the other variables that we might not choose to synthesize, but what kind of uses they have, or what kind of, how they can be helpful in our synthesis process. Okay? So if you have to pick one, which one? Ted?
Probably income.
Okay, so we get a vote for income. Anybody else? Income? Everybody? Okay. And Isaac?
I think he's muted right now.
Yeah.
No, sorry. Yeah, I would agree.
Okay. All right, okay. And I would agree too. So how many we have? Yeah, like everybody pretty much. Okay. Yeah, but okay, so this will be our first choice, let's say. And that is, well, the rest of the slides is focused on. We're going to talk about, like, well, if I determine this one is the most sensitive and I want to do something about it, like I prepared those for this, for that particular scenario. But since we are on this slide, maybe if you pick another one, like an additional one, which one you would pick to be sensitive that you want to synthesize? Or if you think income probably is the only one that is sensitive, so I'm done.
Maybe even expenditure.
Mm-hmm. Okay, you might choose that. Anybody else? And how would you make the decision? Well, last time we talked about if you only have a categorical variable, we sort of show that, well, really depends on the number of categories as well as particular combinations, right? Here we're having continuous variables, which if you follow what we were talking about last time, well, how to think about the risks, it gets trickier, right? Because, well, we all know, well, if you think about them to be continuous random variables, then we know that if it's a continuous random variables, whatever distribution it follows, the probability of that random variable taking a particular value is 0. That's just how continuous distribution are defined, right? So in that case, well, if you think about matching, like, should we match with the exact value? Or should we match maybe in like, say, the true value, like like a ball around that true value, any value like around it within that ball, like an interval. should be declared as a match. Okay, so when I say match, sorry, maybe I'm jumping too far ahead. Last time we were talking about identification risk, remember? And we're talking about identification risk of guessing the identity of each particular record. And back then we're having categorical variable only, so that kind of matching or like comparing, we can just look at whether their categories match with each other or not, right? Like remember the example, like what was it? Sex is 1, race, right? Race is 1. Our neighbor, the picture's neighbor, what is the last one? Marital status, I think. Yeah, like we're talking about this combination, right? And then when we're counting how many observations are sharing the same combination, we simply just do a table, right? Like in R, you can just like count how many there are, because you can do matching exactly on the category, okay? Because they're all categorical variables. What I'm saying here, which probably is not like something we can solve today, but I want you to start thinking about it. Well, when you have income or expenditure, those variables which are continuous, if they're involved, even just without doing any synthesis, if I just want to see how sensitive those variables are, we might want to do some kind of like way to estimate the identification risks, but they're continuous. So what should you do about it? If someone, let's see, we go back to this slide, and yeah, like say those records, first record, income 98600, right? And expenditure, well, it's 3 decimal places. What do we mean by, well, can we do like when we say like they're sensitive or like this record is at high risk, if we match exactly those values or something else? Right? So with urban and race, urban, rural, and race is still relatively straightforward because they're categorical. Like if I want to count how many observations are similar to my first record, or my neighbor whose urban is 1, sorry, urban rural is 1, race is 1, and then maybe, yeah, let me just take the time, I guess, to move this over here. If I know my neighbor is rural urban is category 1, okay. Race is 1, and let's just say income is 95000. Okay. If I know this person, say if I go in here, let's just say that all of the records here, none of them match with this number. Do you feel comfortable that, oh, no risk, let's just release it? Or no? Okay. And I should just like add a quick comment. Last time we had this comment as well that all of the data that we work with now, they're public available, so they're not the truth. Okay, that's why, well, if I go in with this information about my neighbor, I know he makes, well, maybe even my information is not that accurate anyway, it's in that ballpark. What kind of like identification risk can you think of? And like we don't have to like solve them today, but I want you to start thinking about this, because at the end of the day, if we develop a way to synthesize income later, like maybe that's the choice that we all made. So, and that's what I prepared. So that's what we're going to talk about today. But once you generate your synthetic data, when you try to evaluate whether your synthetic data is good enough, meaning that it will have high utility but moderate risk or not really high risks, you will have to figure out a way to evaluate the risks, okay, at that point. So we'll have to face it at some point. So right now, I just want you to start thinking about what you could do. And when we get there, hopefully you'll have some ideas, especially along the ways. I mean, you're gonna do the synthesis process, and then keep in mind that the risks for, identification risk as well as attribute risk, that is guessing exactly the number for that synthesized value, will be questions that we have to solve. Okay, for categorical data, overall straightforward, you just match. But what about something that you synthesize, which is continuous? And then how can you do the identification and attribute risk? Disclosure risk evaluation will be like a topic that we should keep in mind. All right, so okay, so I think earlier we picked income. So if that is the case, so my second question is, well, what kind of relationships do you want to preserve if you were to release a synthetic version of this CE sample? If I believe that I have to synthesize income, what would you choose? What kind of relationships do you want to keep there? When we say keep there is when we have synthetic data as well as the original. If some analyst or us doing analysis, same analysis on both copies, we want to get very close results. Okay? And that's high utility. And then of course, high utility, I mean, each utility relies on what kind of things you want to do analysis or like analysis about. And that goes back to what kind of relationships or dependencies that Sarah was asking earlier that you were trying to preserve. Okay. So what do you think? If I want to synthesize income, what kind of important relationships we want to keep and how that will factor into a synthesis model that we're going to develop? Anyone? I said, yeah, go ahead.
So like we saw from the lab in the last class that there's kind of a linear relationship here. So perhaps like add noise to expenditure and then use the sample linear regression to generate synthetic income values. And if you also wanted to make sure those matched race and urban rural, you might add you might like make the linear regression hierarchical, so like different coefficients linked by a prior for different permutations of race and urban and rural.
Yeah, so you're saying, if I understood it correctly, that you're thinking that the relationship between income and every other variable, if we can, should be preserved, right?
Yeah.
Yeah, so that's definitely, I mean, we can be greedy. We want to keep everything if we can. So of course that will be if that is choice, great. And then I think what Isaac offered as well is, well, what you can do in terms of the modeling, right? So can you repeat that part again?
Yeah, so it'd be a linear regression where like expenditure is kind of your main covariate, income is the output, and then it makes sense to give urban, rural, and race or like the combinations of them kind of their own parameter levels within the model.
Yeah, so right, so I think writing out the model, well, yeah, so I think what Isaac is proposing is we're going to use some kind of regression map model, especially because your income being the outcome or the response variable, which is continuous, then it makes sense to do some kind of regression. But in particular, Isaac is proposing that we're going to do a regression of income given expenditure, so that will be the main predictor or covariate. We also want to keep the relationship about urban and race as well. So he's proposing some kind of hierarchical model that, well, look at, so urban is what? Binary, so it's 2 levels, right? Race is what? 6. So you have 12 different combinations, right? So you could develop a hierarchical model in a way that you can have one, like for each of the 12 combinations, you will have a regression analysis in some way. And then you can generate your synthetic data. Sorry about that, yeah. You can generate your synthetic data from there, and then that will be how you capture the relationship. Okay, yeah, so that totally makes sense. And that will be one way that if you want to keep all relationships, you might go with a regression, and in particular, you use those categorical variables to form like combinations, and then doing some kind of hierarchical analysis. Okay, and then the model estimates, like the parameter estimates that you have for those for that particular model, you will be able to generate synthetic data doing the posterior predictive. Okay. Any other ideas? Like, do you all want to keep relationships of income with every other variable? And if so, did you choose this hierarchical approach or any other approaches that you can think of? it's open-ended, you can design any kind of models you have. And I think that goes back to what Henrik was asking earlier. Well, if we have a bunch of models, which one we should choose, right? Yeah. So I think you definitely can have other approaches. Anybody wants to jump in? So this is income, this is the one. And what kind of relationships, and then how that can be turned into a synthesizer.
I do agree that income should like maintain the relationships with the other variables, but if we wanted to keep it simpler, just like a simple linear regression with expenditure. And what I did with, I don't know if I did it with both variables, but just since I just logged, I remember I did it for expenditure, I logged expenditure so that I could use a normal model. But yeah, I think a linear regression between the two variables, income and expenditure.
Yeah, so if we follow what Henrik is trying to do, then we're sort of saying that, yes, income is the only sensitive, and I'm synthesizing it. And then if I only put expenditure, we can talk about the transformation later, which is a great idea. Like, we want to make sure that the estimates are good in the sense that, yeah. But if we do the expenditure as the only predictor there, we're sort of implicitly, whatever you choose, we're saying that we're only trying to capture that relationship in the model, right? Like, if you don't do anything about the urban and rural, if you do a regression analysis and then that is your Bayesian synthesis model and they generate synthetic data out of it, I mean, in theory, only that relationship will be preserved. Okay? Yeah, so I just want to, like, I guess, say clearly that if you do that, then that's what the relationship you want to preserve, and then let's hope for the best that real simple linear regression will work out fine. Okay? There are certain things, I mean, transformation on those variables, especially for highly skewed variables that we have to do. And yeah, but this, yeah, Henrik's approach is, well, let's try to focus on preserving the relation between these two, and then we can do a simple linear regression. Okay. Any other ideas or questions, thoughts?
I just had a question, thought. Could you ever like could you make the continuous variables into categorical variables just to?
What do y'all think? Harry's question is, well, yeah, dealing with continuous from the modeling perspective, probably not that bad. I mean, you can always do some kind of regression in some sense, if that's what you want to do. But then for the risk evaluation later, I guess that's where you're coming from, right? Yeah. So for the risk evaluation later, if you are dealing with continuous variables, it might just be challenging to deal with. I mean, you can, yeah, there are definitely ways, but who knows if they're appropriate or suitable. But earlier we talked about if you only have all categorical variables, then that identification risk probably is more straightforward, right? So how about for income and expenditure, let's just put them all into categorical variables. And what do you all think about that? Well, yeah, what do you all think about that? Maybe think about it from the synthesis model point of view, because, well, if you have all categorical there, we haven't talked about this yet, which I should also mention that I think in 347 in Bayesian stats, we didn't talk too much about doing modeling of categorical data in the first place. Okay, so that will be something we have to figure out. And also for the synthesis, and then of course from the synthesis, oh, sorry, let me just say from the utility and from the risks. Okay, so let's have a quick discussion among your neighbors. You can like switch partners if you want. I mean, it's a small class, and I said we should be able to figure out a way for you to jump in. And we usually have 7 people here today. I mean, usually, but Ray couldn't make it. So, but I mean, yeah, you can just jump in anytime. We can. I mean, I'm not recording any of those discussions. So let's think about, say, income. Go into a categorical. What's the implication of that in terms of the synthesis model we have to do, in terms of the utility, and in terms of the risks? So yeah, so I mean, I think people are open to do categorization, or yeah, this kind of discretization, as people usually call. You discretize a continuous variable into a categorical, And then we can do that, but we need to make sure that we know how to do the synthesis, and it probably will help a lot with the risks evaluation, given what we know so far. But what about the synthesis and utility perspective? Okay, so let's take a quick quick discussion time, so we can exchange some ideas. All right, so what do you all think? Like, how can we do the discretization or categorization? And if we do that, any kind of, what are the implications for the synthesis models, for the utility, and for the risk? Anyone? If you were to discretize income, we have, I think in this case, about 900 or like 1,000 observations in the sample. What would you do if we try to discretize it? Yeah.
So like me and Ted talked about like how we can potentially use percentage quantile to break the values into different categories. So in that way we have like the same amount of people in each category. And we also talk about like we can maybe use like equal intervals. It's like say $1,000 interval to create the categories, but in that way we'll probably have a lot of people in some category and fewer people in like other categories.
Yeah, so I guess, I mean, intuitively there are two ways, right? One is, well, you want to break them, let's just say we break it into a 5-level categorical variable, okay? So if, I mean, again, that number, I mean, is arbitrary. You might want to do something else, but just for a demonstration or illustration purpose, let's say we want to break it into 5, then there are two ways. I mean, naturally, there are two ways you can do it. Either you, that's the thing. I think I didn't include the range of this income variable, but you all have the data set, so we can play with that later. But two ways you can do it. One is thinking about percentile. So if you were doing like 5 levels, so we group everybody from the 0th percentile to the 20th percentile and group everybody into category 1, right? And then everybody category 2 from 20th to 40th, and et cetera. So if you do that, you're gonna have a equally balanced categorization or discretization that you're gonna have maybe roughly about 200 people in each group or each category, okay? So that's one way. And the other way is using fixed intervals, like, so if I know the range of this income variable, then I just like, maybe, get like 5 different intervals with the same length in terms of the value, right? In terms of value for the income. And if you do that, depends on how skewed the data is, you might get, I don't know, but definitely like not equally distributed into 5 categories. Okay, so there, I mean, 2 ways you can do it, and so let's just say method number 1 and method number 2. Number 1 is equally distributed across 5 categories. Number 2 is equally in terms of the interval length, but will be unequally distributed in 5 categories. So what do you think? What do you think the implications of either method, if you want to talk about them, or both of them, if you want to compare, in terms of the risks? Sarah?
I think probably the risk is much lower if you do percentile.
Because?
Because as you get probably higher in that income bracket, so the last fixed interval, it'll be much sparser than the ones before, and so maybe you have more. I mean, if it's 5 level, maybe not as much, but if you had like 20, the disclosure risk is much higher.
Okay.
I think you could see a decrease in utility though if we did percentile. I mean, depending on what you look at, what you're looking at.
Yeah, so good. So in terms of risks, we know, well, in the past, I mean, last time when we were dealing with all categorical variable, we know that, well, whether one record, like how risky one record is how unique the records combination is, right? So if you have, so what Sarah is saying, if you have the percentile approach where you have roughly 200 in each, let me just use that number, in each category. So for any record, well, of course, depends on urban and race, that categories, but in general, like you have evenly distributed counts in terms of how many observations fall into categories. So intuitively, you're gonna have probably fewer risks, especially if you compare to the count where you have, so Sarah's example is, well, for the last group, if we're doing the fixed interval case, maybe, because it's gonna be right skewed. So you're not gonna have many records into the last bracket or the last category. So let's just say it's only 5. I'm just making this up. So if it's only 5, and then, I mean, the remaining 185 from this is gonna be like distributed in the previous one, right? We don't know how that is done. Depends on how the data is. But if you compare, so this is the implication, I think, on the risk. If you compare this to, right? I mean, because for, let's say, because for, let's just say urban and race, let's not worry about expenditure for now, but urban and race, I mean, those are right now fixed, right? So for each record, for a particular record, let's just say urban, rural is 1, and race is 1 as well. For this record, if it falls into this, or it falls into that, it means very differently for the risk profile, right? Because, well, it just depends on how unique that record is. If it's in this category, then, well, if you just random guessing is 1 of 200 chances, right? Probability. Whereas if you are in this case, then it's 1 out of 5. Okay? So I think in terms of risk, it's probably easier to imagine, like, say, how things will go. But I agree with Sarah, like for utility, it really depends on how you think of it. The thing is, when you do discretization of a continuous random variable to a categorical, you're losing information regardless, right? Like depends on, I mean, you can do like super fine discretization, like I do like 1% for each. I have like a categorical variable with 100 levels. Well, you can do that. It probably loses the least information because you still keep them in some way. It's still very fine. But whenever we do discretization, I think we want to make our life easier. So we probably don't want to have that many levels in the first place, right? And then if you do that, definitely some kind of losing information. Okay, and just a side comment here, when we're talking about categorical, say we're doing this 1 to 5 thing. This is usually, especially if it's income turned categorical variable, it's actually an ordered categorical. So if you know from your intro stats course, like for categorical variable, there are 2 subcategories, subtypes. One is unordered categorical, like marital status, or race. Here, there is no order, right? They're just like arbitrarily labeled in this way. Or it's something like income turn categorical, that it is based on percentile, so there is some inherent order in it, so that's ordinal categorical variable. And then, so like 5, if we define like 1 through 5, 1 is making the list, and 5 is making the most, then the modeling approach to that will be different, right? Like 1 has no, like, which has no no ordering information at all, you might choose one type of modeling. But then if for the other one, you have some kind of ordering information there, you will have to take another approach. Right? So those are good to keep in mind. But I agree, I think in terms of risk evaluation, will be much more natural based on what we have done already. But then of course, like I said, we haven't talked much about how you can do synthesis for categorical data in the first place. And also depends on whether it's ordered or unordered, and you're gonna have to have different approaches. So I think those are good to keep in mind. I mean, sometimes, I mean, I worked on project that, well, categorical was much easier to deal with, so we turned everything into categorical. In a sense that, well, for the risks and also the modeling, well, if you already know certain models for categorical data, then everything follows from there. Okay, so I think that's an overall intuitive strategy. For us, just keep in mind what any kind of changes or like modifications that you do for the data, to the data before you do your synthesis, you just have to think about, well, the implications for the models, for the utility, and for the risk evaluations. Okay. Okay. All right. Okay, that's a good exercise. So, all right. So I think one last thing I would add here is, if you again think income is the only one, and if you want to keep all relationships there, you can do a multiple linear regression, right? Like, well, yeah, you can do a multiple linear regression that using all of the other variables as predictors or covariates, and then it will go into the model and then you estimate. So that will be also a natural thing to do. And as you could imagine, whatever models that you propose, if you actually end up doing analysis using exactly that model, that will be the best model for you, right? Because say if I say, let's just say 2 types here. The first one is what Isaac proposed. And the second one is just a multiple linear regression. Yeah. Isaac's one is, well, we use income as the response, expenditure is the main covariate, and then we do some kind of create particular combinations given those categorical variables and do a particular hierarchical model from there. So if you imagine that we come with 2, like we used to, and then we get a set of synthetic data for the first one and a set of synthetic data for the second, and then, well, the analysis, like to compare, in some sense, to compare which one is better, probably really depends on what kind of analysis that you want to do. Say, if I really care about the relationship of income given urban, rural, race, and expenditure, if I'm really just doing a multiple linear regression as my analysis, then this one is probably better. Okay. Whereas if I want to look at the income given expenditure, that relationship, but for different combinations of urban and rural, then if that is the analysis goal, then ISEX is probably better. Okay, so just keep in mind, I think we're just trying our best here. We're trying to like say what kind of relationships are important to keep. And then of course, the flip side of all this kind of methodology is, well, it really depends on what kind of relationships and how you're preserving them, because whatever is not preserved probably will never show up in your synthetic data. And I think earlier, Kevin and Henrik, you were just discussing, like, you're saying something.
Oh, yeah.
Yeah. Do you mind sharing it?
I was just asking, like, from somebody who, like, will get the data afterwards, after it's already been processed, and say you find, like, a trend or something, that how do you know if that trend was put in by the original agency changing the data, or is it that true, like, from the actual data itself?
Yeah, exactly. So, yeah, so Kevin's question, which is, I think, is totally legitimate, that if I get my synthetic data, because for users, we never have access to the original, unless you do something like what I told you earlier. What I did is I actually did all of the, what was it? Like, you have to get all of the security checks to access those confidential data and all that. But it's, I mean, time consuming, costly, like, to do that kind of research. So that's why people like to release public use data, that it can be useful as much as they can, because then people don't have to travel and then do all of that. But anyway, so yeah, Kevin's point is that for the end user, having access to a synthetic data and then trying to do some analysis and then find some signal in the data, maybe some particular relationship, say income with expenditure. How do we know, or how does the user know for sure that it's not something made by the synthetic data because of the synthesis model, or it is really some signal in the original data as well? So that is actually something we probably wouldn't be able to answer at all, in a sense, right? Like, it really depends on, like I said, the caveat or the flip side or the drawback, I would say, of the entire approach here is that it highly depends on how you devise your synthesis model, and then how related, or how are they related, like the synthesis model and the analysis model, like analysis model they use in the end. Yeah, Sarah.
How much disclosure is required on, like, the method of modeling? Like, because you could go back and read how they get the model and, like, from that understand or like make a decision of, like, do you think it came from the synthesis or from the?
Oh, I see. So you're saying that whether when public available data is released, whether any kind of like metadata or any kind of information about the synthesis is being released? Yeah, good point. And that's also actually something that people like to discuss. Well, what do you really want to release, or what do you really have to release? For example, a paper that I will ask you all to read for next time is talking about, so the Census Bureau, US Census Bureau, they release, if you go to their website, so many of the public available data, they will tell you a little bit how they add noise or how do they do the privacy protection. And Census Bureau does have a few synthetic data products that the public available data is actually undergone synthetic data like synthesis. So one of them is called, you will see that it's called the Longitudinal Business Database. LBD, oh sorry. Wait, LBD, business data, sorry. Business data, something like that, yeah. The short is LBD, sorry about that. And if you go to their website, you will see that they have this thing, LBD, because the public available version of the longitudinal business databases, that's why it's data, yeah. Sorry about my writing here. Yeah, so they have what they call SYN LBD, and that's what they release, okay? And they tell you it's undergone some kind of synthetic data process. And the paper that we're gonna read for next time is about the first paper of how they made the synthetic or synth LBD in the first place. So if you read that, well, you can tell exactly what they did, right? Like they tell you exactly what they did for all of the variables, how did they synthesize them. So, I mean, in theory, you could, I guess, for a smart intruder, you might figure out something. And like say, because if I know how the data was synthesized, well, can I re-engineer to get back to whatever? So that's a legitimate risk, I would say. I think right now people, yeah, to the best of my knowledge, I don't think people worry too much about that at the moment.
I think my question is
Oh, yeah, go
more
ahead.
that for people, well, not really, like the motivation is like for people who want to see, like if they find a signal in the data, not that like they're an intruder, but if they find some correlation if they're using public data, like how they would make sure to check.
Oh,
like
okay.
if that was coming
Yeah,
from
I
the
see.
data,
I see.
and if they know kind of the method of
Okay.
synthesis,
All right.
since they can make an argument either that it's from.
Yeah. No, that's a good point.
Okay.
So let me just hold this here. I'm not gonna, yeah, if we come back to this, I'll just talk to you a little bit more about all of that kind of stuff. But her Sarah's question, for data users, once they find some signal using the synthetic data and then they want to verify, one thing people have been promoting and advocating, I would say, is what they call, I might not, yeah, I might be wrong about the exact terms, but what they were trying to do, well, I should say, the field is changing all the time. So this is, at some point, this kind of idea like was proposed, and for a while people liked it. So what that kind of approach, remote access, and also like research data center, that kind of idea is that, well, what if you have a group of statisticians who actually work at those statistical agencies? They are the holders. I mean, they like pass all of the security checks. They can have access to the original confidential data. And how about people can make requests to those groups where they say, okay, I really want to get a sample of the consumer expenditure survey. And in particular, I want to keep the relationship between income and race and expenditure and urban rural status, that kind of stuff. Then if you make that request, those statisticians or data scientists, whoever working there, will choose the appropriate models. For our case, maybe just a multiple linear regression, who knows what it is. They can do that kind of synthesis given the requests. And then they actually will return to, what they're gonna return to the data request or the users is not only just the final, like say, regression coefficients of what they requested, but also how close they are to the truth, something along the line. Yeah, so this was definitely a thing, I think, a while ago. But like I said, I think the field is changing all the time. I mean, towards the end of the semester, I will talk to you a little bit more about a growing subfield of all of this that last time I told you about, that right now when we're thinking about risks, we have to make assumptions about what the intruder knows, right? And that can change, and then that can give you like a different assumption, can give you like totally different kinds of risk profiles, and yeah, risk profiles in particular. So people like attack this kind of approach, like why would you do that? Why don't you, can you figure out like a worst case scenario that no matter what, like is protected? So that was the other thing that I told you last time, which is what people call differential privacy. It's a form of privacy guarantee that, well, if your two record, like two data sets, if they only differ by one record, the summary statistics or whatever that you return on each of, like on either of the two data sets wouldn't change by a certain ratio. Yeah, so that is become, I think, it's becoming one of the main methods now, in a sense that, well, that is formal guarantee, like people won't be able to know anything about a particular record or et cetera, et cetera. But that, again, comes more from the risk perspective, that they want to minimize the risk in the first place. But when they do that, the utility might be really bad. Okay, so that's, I mean, that's, I think, the challenge in that subfield of how they can guarantee the risk, but they have to improve their utility as much as they can. Whereas from our side, if we already know what kind of relationship we want to preserve, we design Bayesian models based on that, then in theory, the models are good, and then the synthetic data will have really high utility, but we have to justify the risk. So you will see, I mean, that's how I think the whole field is being shaped now. And then the remote access and also like those requests that I mentioned to you, I think it was definitely a thing at some point. I might just have to check, like say, how is that going? But most of the time, what we do, like as data users, you go to whatever statistical agency's website that you're looking for the data for, and then you can read about what kind of protection methods has been done. And then for the synthetic LBD, the longitudinal business databases, next week, I mean, you will read that and you will see exactly, well, this is all of the procedure that they did. And if you want to be smart, you might want to like try to like re-engineer to go back to see if you can recover some of the truth if you can. Okay, but that's a good question. I mean, so for the signal, well, whether it's true or not, I think, yeah, only God knows. I don't know. Like somebody, if they had the kind of remote access process, Curie process like that, then they can verify. Otherwise, it's really, yeah. I think that's another huge challenge in this field. Okay. All right. So. Yeah, so one last point about the same LBD before we move on. So I mentioned this mostly because, well, there are documentations out there about how data privacy or like protection methods are being done to those public use files before they're released. And if you're particularly doing synthetic data, we know that they're generated from Bayesian models. Like you apply models on them and then you generate synthetic or fake data from those parameter draws. So there was also once we were discussing or debating whether instead of the data, like say the predicted values, like all of the Y stars, why don't you just give them mu's? Why don't you just give them or release not the data, but release the parameter draws from the model or whatever that is. So that's another thing I would just mention, that there was this discussion in the past, and you might have your own ideas of whether, I mean, in the end, I think people usually just generate, like release synthetic data because for many end users, they probably are not that sophisticated. They just want to have a data set to fit into their statistical program. They probably don't want to know about, yeah, anything else, for example. So that might be the main reason why, but yeah, in some sense, I mean, maybe every relationship that you want to get can already be captured by those parameter draws instead of the actual synthetic data. And then that might be another thing that people can do if they want. Okay. All right. So let me actually just go forward. All right, so to start simple, I think what I had here is like, let's just assume income is the only one, and let's just assume that, so we had some kind of discussions here. What I listed over here is that, well, before you design your synthesis models, you have to think about what kind of relationships you want to keep. And then of course, given that, you have to think about the appropriate Bayesian models. And then, of course, how to estimate the models, and then how to generate synthetic data out of them. That will be what we focus, probably not only today, but next Tuesday as well. And lastly, how do you evaluate whether your methods have achieved the goals? Okay, so those will be for later weeks as well. So what I want to focus now is, let's just say income, and let's just start simple. Let's just say that we want to preserve the relationship, following what Henrik was saying. Preserve the relationship between income and expenditure. Let's not worry about the other one. But I want to give you a flow of, say, if I decide to use this particular model, how can I estimate the model, and how can I generate synthetic data out of the model? Because once you know this flow, once you know, like, say, in practice, how is your like R programming and all that, you can use either like the multiple linear regression models, or what Isaac was suggesting, doing a hierarchical model. You can do whatever you want, and then you'll be able to generate synthetic data out of them. And for next time, I would like to have you all like present a little bit of what you would have done, like what kind of synthesis model you're going to use. For today, as much as we can, I'm just going to cover, well, I'm just going to do a simple linear regression, and let's see how the procedure is going. Okay. All right. So